please welcome to the stage Dominic Williams, founder and chief scientist of Dfinity Foundation, and Bettina Warburg, co-founder and managing partner of Warburg Saris Investments.
Hi, I'm Bettina Warburg. I'm super excited to be here with Dominic Williams, founder and chief scientist of Dfinity. Dom, it's been a long while since the early days of Pebble and Phi and some of your early work on the ideas that went into the Dfinity internet computer. And now we're, 24 hours from the launch of the Genesis block. You must be pretty pumped and feeling good, right?
Yeah, I'm super excited. I'm amazingly proud of the team that's taken the project this far. Obviously, there's a lot of pressure that remains. This is a big deal, and it's the beginning as well. It's not the end. The internet computer is the world's first fully adaptive blockchain. So it runs under the control of this thing called the network nervous system. And the network nervous system has complete control of all the hardware in the network. It runs on dedicated special node machines which are installed around the world. And the network nervous system, can upgrade these node machines to improve the protocol, unlock features. It can increase capacity by combining node machines into new blockchain subnets, tweak economic parameters, and so on. So Genesis is happening. People are going to start making neurons so they can participate in governance, and then the evolution of the network will continue. But this is a major step for the Dfinity Foundation and the Internet Computer Project, and I think it's going to be an absolutely giant leap for blockchain. I think people are going to see something that just absolutely blows their mind.
And how did it really come to be? I mean, what has been the journey to get to this place and the Genesis?
Well, it's been a very long journey with plenty of bumps. You mentioned Pebble earlier. So, back in sort of 2013, I was, beginning to work on and look at blockchain architectures that could scale better and would run faster. In 2014, I was working on something called Pebble, and we sort of didn't go ahead with that project. I spent a lot of time on the Ethereum circuit, and I became very inspired by the sort of the world's computer vision. And something as well struck me, which was that smart contracts are really a profoundly different new form of software with absolutely vast advantages. And so in 2015, I began to ask the question, well, if smart contracts really are this profoundly new form of software with vast advantages, what would happen if you could remove the limitations? What would happen if smart contracts could run at web speed? What would happen if smart contracts could serve web? What would happen if there's unbounded capacity? So you can scale it out without limit. What would happen if they could run efficiently? And my conclusion was that there'd be a kind of blockchain singularity where everything would be rebuilt on blockchain: websites, systems, services, everything. And not only that, but because smart contracts have these different these different new capabilities and can imbue systems with new properties, in the process of migrating to blockchain, systems and services will be completely reimagined. And that excited me enormously. And so, back in 2015, I was talking about crypto ledgers that could, host internet, mass market internet.
I remember those days.
Yeah. And, I think, I used to propose a lot of kind of applied cryptography and distributed computing protocols. And But back then, the ideas seemed pretty wild, and people were interested in them, but I don't think anyone really thought it could ever be done. And being foolhardy and optimistic, I said, well, I can do this. This is doable in a couple of years or something. And here I am. 6 years later, we've achieved it. We're delivering the internet computer. It does host smart contracts that run at web speed, that serve web. It has unbounded capacity, but it was a big job getting here. And we've had to build blockchain's biggest R&D operation. We're almost 200 people strong. We've got research centers in Zurich, Palo Alto, San Francisco, small one in Tokyo, remote teams in Germany, the UK. We employ some of the world's preeminent cryptographers, some of the world's best engineers, and we've had just to sort of engage in a sort of research and development effort on an unprecedented scale. And the internet computer is 100% new. It uses new architectures, new protocols, new mathematics. There's new cryptography, new applied cryptography, new execution environments. Everything's new. Smart contracts can run concurrently in a deterministic way. Getting all this working was just a huge, huge undertaking. But we stuck to our guns, and so I'd like to thank everyone that sort of waited for this project, because I know it's taken a lot longer than was originally hoped.
In some ways, though, you're talking about restructuring how we even do software development, right? We're looking at more like autonomous software and this entire architecture that it's built on, and even the transition we've seen with WebAssembly. And there's really a whole host of things coming together at the same time to transform the next iteration of our internet.
Yeah, that's right. There are many different technologies that have come together that have made the internet computer possible. And I'll give you one simple example, which is internet identity. So the internet computer supports something called internet identity, and actually other blockchains could adopt this too, and use this as a system that runs off the internet computer. So internet identity allows you to authenticate yourself with your devices. You never touch a username and password, and you never touch public or private keys. Essentially, it relies upon a protocol called WebAuthn. And WebAuthn allows web browsers to interact with TPMs, these secure chips inside your devices, like Android phones, iPhones, and laptops, that hold cryptographic key pairs and can consign messages inside the chips, and also HSMs like ledgers and YubiKeys and Trezors and Nitro keys. So with an internet identity, you essentially have, and you can have as many internet identities as you like. You have a phone number which keys you into it. You don't have to keep that secret. And to this identity, you can add any number of devices. So you could add, for example, you could create an identity you use with social media, and you might add, your MacBook Pro, and you'd authenticate yourself on that by pressing the fingerprint sensor. You might add your Pixel phone and use Face ID, and you might use a YubiKey for backup, say. And you might have another identity which is for use in DeFi, which just uses a bunch of HSMs. What's so cool is that you can sign up for internet services running on the internet computer and log into them from any of the devices you've added to your internet identity. So, let's say 1 minute, you're on your laptop and you want to log into OpenChat, this project some people are building on the internet computer. Literally you put in the URL of OpenChat and press the fingerprint sensor and you're in. The next moment you're out and about and you want to get into OpenChat from your phone. Okay, just if it's on an iPhone, just hold it up, right? And get in via Face ID. So it's far more convenient than usernames and passwords and far more secure than usernames and passwords. It provides all of the security of cryptography, but with this vastly better user experience. And that's been enabled by a number of things. On the back end, it's something called certified variables that the Internet Computer supports. And then on the client device, it's this thing called WebAuthn.
So let's talk a little bit more then about what are some of those open internet services. You mentioned obviously open chat. We've seen Linked Up. There's some examples of CanCan. Sort of where do you see open internet services going, and what are going to be the sort of first building blocks necessary?
Well, I think it's very difficult to imagine what's going to happen because smart contracts can be used to create any number of systems. So it's very difficult to predict human creativity. But I do think that we're going to see the tokenization of absolutely everything. So, at the simplest level, you're going to see the blending of DeFi with social media and SaaS services and things like that. So look, at a simple level, you could create something like a ride sharing service. Let's call it Open Rides, and it would be controlled by governance tokens, and those governance tokens might be given out to early riders and drivers to incentivize participation. That's a very simple application. You might do something more sophisticated, like for example, you might create open photos as an alternative to Google Photos. And one of the drawbacks of Google Photos and iCloud is that you have to put your credit card in to pay for your photo storage. And if you're taken ill with COVID and you're in hospital in a coma for a few months, or you go under a bus, the credit card will expire and all your photos get deleted. And in fact, this is a problem that people regularly have. Bereaved relatives often find themselves trying to negotiate with Google and Apple to gain access to these accounts before all the photos get deleted. Okay, so that's no good. How could we use DeFi? Okay, well, on the Internet Computer, obviously these photographs will be stored on chain because the Internet Computer doesn't have capacity limits. You might create a system where people can make a deposit just once, and then that deposit would be entered into a DeFi margin lending scheme, say, and the interest earned would be used to pay for the storage on the Internet Computer memory pages that contain the photographs in perpetuity. So, for example, you might make a deposit that gives you an eternal terabyte of photo storage. So I think there are really creative ways that DeFi can be used within the context of internet services. I mean, we've got this app called CanCan, which you mentioned, which is it's not something we're going to launch. It's just really designed to illustrate the different tokenization strategies you can use. And it looks very similar to TikTok, if you've ever used TikTok. What we've done is we've introduced a bunch of tokenization features. So for example, in addition to the like button, you now get this super like button. And you get 10 super likes every 24 hours. And the idea is that you can super like videos that you think are going to go viral. And so, for example, you're allowed to super like videos that have got less than 25,000 likes. And if that video does go viral, let's say it gets 250,000 likes, you participate in a shower of reward points, which are of course tokens. And maybe that happens, every time a milestone's passed, 250, 500,000, 1 million, and so on. So these reward points have value to the users. And so, you're driving engagement because people are now trawling through more videos, looking for videos that they think are going to go viral, and they can place one of their 10 super likes on, a bit like betting on horses. That's creating great signal for the content ranking algorithms. But we also use these reward points to create a sort of microeconomy. So periodically there's a drop day, and on drop days you can exchange reward points for CAN governance tokens. So as a user, you can become a part owner of the service. But you can also exchange them for prizes that are offered by advertisers, because advertisers need reward points to pay for advertising. So that's an example of how you can create a kind of microeconomy. We also use reward points to engage users in moderation. So when videos are uploaded, initially they go into an unmoderated feed, and they have to survive there for an hour before they go into the moderated feed. And those users that have signed up as moderators get 100 flags every 24 hours, and they're placed in a game where they have to flag videos they think should be taken down. And if enough other moderators also flag those videos, they're rewarded with more flags and of course reward points. So the great thing about that is that anyone can become a moderator. There's no job interview, and they don't need to be managed. The system uses algorithms and tokenization just to ensure that people are rewarded according to their success in moderation. So if you look at what's been done, we've increased user engagement by allowing them to super like videos they think are going to go viral. We've created these sort of viral growth flywheels. We've got signal for content ranking algorithms. We've created a microeconomy where advertisers are offering prizes in exchange for reward points because they have to pay for advertising with reward points. And we've engaged users in moderation. So actually, if you look at it, as a sort of abstract, from more of an abstract view, but Facebook introduced this idea that the user is actually the product. So Facebook puts users on this kind of hamster wheel, and you're constantly shown content. When you click on something, it feeds you more content like that, to keep you clicking and keep you engaged. While you're on that hamster wheel, Facebook's learning things about you, and then it sells access to you to advertisers, which is made more valuable by the knowledge of your likes and tastes.
And you're also locked in now on this particular.
Yes, and you're locked in. Yeah, nobody can.
So your value. That's in some ways, what you're describing really, to me, sounds like a future of super apps. You said microeconomy, which I think is also a valuable term in this space, but you're almost able to create incentive structures that are aligned with user behavior and user desires. And then foreseeably, users could be building apps on top of these sort of underlying services. And we'll see, hopefully a flourishing of new kinds of user experiences that maybe we haven't seen before, because they're not incentivized to build on top of a Facebook or a sort of closed platform today.
Well, that's right. Facebook's opaque, and people are locked in and the data's locked inside, yet the users are the product. With something like CAN, users, well, firstly, it'll be controlled by an open tokenized governance system, so it's transparent rather than opaque. But users are also able to become owners of the service, and moreover, users are engaged as the team in tasks like moderation. So rather than users just being the product in an opaque, privately owned service where their data is locked in and which can't be extended by the community, they instead engage in an open, transparent service where they can become owners through participation and are engaged as the team that runs it. So that's a very, very profound change. And you also mentioned something about extensibility. So one of the greatest powers of smart contracts is that any smart contract can plug into any other smart contract with permission. And that's one of the key reasons we've seen such explosive growth in DeFi on Ethereum. When one person creates a decentralized financial system on Ethereum using smart contracts, anybody else can potentially extend it by plugging their smart contracts into that. And smart contracts, shrink the distinction between static software and dynamic software. So, whereas in the past we built new software systems by composing static software, such as linking in a software library. Now we're doing the same thing with running systems. When you plug one smart contract into another, you're not just linking the software, you're linking the systems. So, smart contracts provide for service composability, and that's what creates these network effects, and that's why DeFi has been so explosive. But those same dynamics also will apply in other fields too. Everybody who comes to the internet computer to build will be able to potentially integrate with all of the pre-existing smart contracts that have been configured in an open way. And so as more and more people create these smart contract-based services, of course, there are more and more options for people who come to build. And that's incredibly powerful.
I mean, it's an incredible vision. I feel like, we are on the brink of a new era of the web. And really for you guys, we're 24 hours from Genesis, essentially, right? You have maybe 250,000 people joining to view the launch. Tell me a bit about that. What's sort of on the docket for tomorrow? And we'll be holding our own watch party at Warburg Ceres, but I know, there's probably a lot going on in the background for you guys.
Yeah, so there are actually two events. There's one in English tomorrow, and there's one for the Chinese audience on Saturday. Genesis Unlock happens just very shortly after that, and we'll give the exact time during the event. We've got 120,000 registrations for the event tomorrow, and we're expecting 250,000 attendees in the China event. So that's like 370,000 people. That's the brave new world of blockchain today.
That's incredible. And so, if we fast forward, past launch, and now we have people exposed to this live network, what are your hopes? What are you going to see people build, or how should we be telling people to actually go and start building on Dfinity?
The reason this project was begun all those years ago was because of the intuition that smart contracts are profoundly different and vastly superior new form of software. And we think smart contracts will rule the world. We want everything we build using smart contracts. So we don't want people building on traditional IT. We don't want to see people using cloud services and traditional databases. We want people to rebuild everything using smart contracts. We want people to rebuild websites, systems, services, finance, the whole lot using smart contracts, and reimagine it in the process, because you can do entirely new things with smart contracts. So in a way, we're chasing a kind of blockchain singularity. And the internet computer is a very advanced public blockchain system that's designed to run at internet scale to make this possible. So, we are focused on the long term. I personally think about the following milestones being 5 years, 10 years, and 20 years. I believe that decentralized finance will be significantly bigger than traditional finance in 10 years. We're going to see enormous change. With respect to the network itself, look, it's the first fully adaptive blockchain. It runs under the control of the network nervous system. That runs inside the protocol and is integrated with the chain key technologies, if you've heard about those. It's one of the biggest achievements of the project. And all of the hardware in the network runs under the control. All of these special node machines run by independent parties and independent data centers around the world run under the control of this network nervous system. It can push upgrades to those machines to upgrade the protocol, to fix things. And it also can configure the network. So, for example, it increases capacity by creating these things called subnet blockchains as needed by combining nodes from independent parties. It can tweak economic parameters and so on. So, once Genesis Unlock happens, lots of people are going to be creating voting neurons, and the network nervous system is going to exert the will of the community, mediated through algorithms, and evolve and adapt in real time. So no one's ever seen anything like that before, and not within blockchain, not outside blockchain either. We're going to have this huge kind of infrastructure that's not only governed by a protocol, but to some extent pursues a strategy. The internet computer wants to succeed. It wants everybody to build on it. And the network nervous system is designed with sort of cryptoeconomic considerations that will ensure that the way it decides on proposals which are automatically executed will tend to drive the success of the project. So this is also about, what can a decentralized network with a decentralized kind of brain, if you like, do against, traditional infrastructure run by companies, large companies with boards and so on. So I think it's going to be absolutely fascinating to see what happens. But we're very optimistic, and the momentum behind the project just keeps on growing. And we're going to ramp up. For us, this isn't the end; it's the beginning. We're already the biggest R&D effort in blockchain by far, but we're going to keep on accelerating how we ramp that up.
Well, I think it's the blockchain singularity, as you said. A lot of people are going to be paying attention. I hope a lot of people tune in tomorrow for your launch. Thanks so much, Dominic.
Yeah, please do. Thanks, Bettina.